Hey everybody. In this video I'm going to talk to you a little bit about standard input, standard output, and standard error, three pipes that every program has in Linux that allow it to just communicate in a very standard way. I'm going to show you some example code written in Yasm assembly, but assembly knowledge is not necessarily required for this video. You can just sort of follow along. If you're interested in learning more about assembly, see my other videos. Anyway, what is standard input, standard output, and standard error? Well, for starters, every program has, every program that gets launched, under the hood, the operating system will typically attach three pipes to it. Basically, one for standard input, one for standard output, and one for standard error. Standard input is where you can send input into the program pretty easily. So let's see. I know what to do. There's an echo command, right? So here's the program called echo. When the program launches, it's going to have three pipes attached to it, just like I told you before. These pipes also behave as file descriptors, as if you had opened a file, but their file descriptor numbers are always 0 and 1 and 2. 0 for standard input, 1 for standard output, and 2 for standard error. So if I launch the echo program, it's going to get those three pipes, those three file descriptors, and right away, the standard output is going to get attached to the program running our terminal here, or well, not necessarily the actual terminal, but bash under the hood, which is the program that we're using to interact with the operating system. So basically, the program launches, and based on this incoming argument that I give it hello, then it's going to print the string hello, right? But what it's actually doing is it's printing to its standard output pipe, its standard output file descriptor. I can test this for sure by just sort of doing the command again and then muting its standard output pipe with this little shell trick. I'll do a arrow or a greater than angle bracket, and I'll just send the first pipe. I'll do 1. I'll send it to dev null. And on Linux, dev null is just, if you send anything there, it just goes away. It's just totally ignored. So if I send the pipe labeled number 1 to just nowhere, then notice how it doesn't show on the terminal for me, right? It's pretty cool. Let's go a little bit deeper into this. I just want you to see real fast, before I write an example program in assembly, what you would probably end up doing in C++. So we usually do something like IOStream, integer main, whatever, return 0, and maybe we'll say using STDCout, STDERR, STDNL, and so forth. And then if you actually want to print a message to the user, we'll say cout. This message prints to STDOUT, because that's what cout does by default. And then if we do cerr, a lot of people haven't actually seen this, and I personally always forget that it's even there. If you print a cerr, it prints a message to standard error. Why would you want two different pipes that printed messages, and one is called output and one is called error? Well, like I've said before in other videos, it's really convenient to be able to have programs automate other programs. For example, if you have a program that is launching, a second program, maybe the second program fails in some way or wants to complain to you in some way, it would usually, if it's smart, print the complaint to standard error. It may not actually use cerr because maybe it's not a C++ program, but it would print to pipe number 2, file descriptor number 2, standard error. And then that way the program that's launching it can just sort of ignore messages that happen on standard output, because we can assume all of those messages are just normal info messages that a human might want to see, or maybe you want to record to a log or something somewhere and just kind of save it away. But the error messages are a little bit more important than the regular, normal messages. So if you're automating another program, then your program probably wants to take standard output and either ignore it or just kind of send it to a different file. And then it wants to take standard error and pay more attention to it. Write it to a log file, save it, maybe check that it's actually blank. And if it's not empty, then maybe alarm bells go off, something went wrong. We have to alert someone, or, make a database entry, send an email, whatever. And just pipe 1 and pipe 2 is how you accomplish that. So this is what's happening in C++ when you do that sort of thing. Okay, so now I would like to write a sample program that just kind of demonstrates this real fast. So please bear with me. I'm going to go really fast for the assembly portion because this is not an assembly video. If you want to learn more about how to write assembly in the first place, then see my other videos. For now, I'm just going to create a little blank file here. Let's see, where the heck is my window? I'm on a multi-window system here. Okay, so I'm just going to paste a little data section. This is Yasm assembly. A little data section, I'm just going to fill it up with strings. I'm going to make a string for the introduction. Hello, the module has started. A string announcing everything that we're going to do. We're going to begin printing to standard output and standard error, and then some messages that will go to each, and then a standard input string, which we'll talk about after the standard output and standard error. So just a bunch of strings. I'm going to make a buffer size. I'm going to make system call codes for reading, writing, and exiting. If you want to know more about system call codes, see my other videos. And some file descriptors. This is exactly what I just talked about. The file descriptor for standard input is 0. For standard output is 1. For standard error is 2. And then I'm going to do a system exit code of 0, which actually doesn't matter that much, but I'm going to do it. So now I'm going to make a, let's see, a global, make a global, no, did I already make the text section? Here we go. So there's the text section. So the data section is over now. I'm going to make the text section. I'm going to make a global entry point called start. Again, if you want to know more about assembly programming in general, see my other videos. But so this is the entry point of our program. At the very end, we should probably just program that it exits with success and test it out real fast. So basically, right now, this program does nothing. Let me just double check. Clear and make run. I have a makefile under the hood, but this is not a makefile video. If you want to know more about makefile, see my other videos. But basically, it just starts running and then it just dies right away. Okay, no problem. Let me actually, I want to fix that makefile because it's labeled after like a different project that I was doing. Let's do, there's no need for me to even do this. I just can't help myself. Okay, so there we go. All right, so now going back to the editor, we have a program that does nothing. I'm going to copy paste in a couple of useful functions that I use elsewhere. Again, this is not an assembly video. So you can look at my code if you want to, if you just kind of want to know how this works, but not the point of this video. So I'm not going to spend too much time. Maybe I'll just briefly talk about what it does, but not the point of this video. So the first thing I'm doing is I'm adding a function called print null terminated string. Just, it sweeps through a string, or actually it asks another function I made to find out how long the string is, and then it'll print the string to some file handle that I gave it, like standard output or standard error. And, it calls on this other function called string length, which I just wrote in pure assembly for fun, even though I didn't need to. And it just kind of sweeps through the string until it finds a 0, and then it knows how long the string is, and then CRLF just prints a carriage return new line, just with the same idea with the print null terminated string function. And you can see all my strings have null terminators. That's the .0 at the very end of it. Okay, so we got those helper functions. The next thing that I need to add in here is oh, let me do an intro. You like my growling? I used to have a professor who would go, and he would go, oh God, when something went wrong. And I do that all the time, even when things are going right. Okay, so I'm going to paste a little function here called intro, and this is not going to be anything important. It's just going to print a little hello message. It just uses my intro string and then just prints it with those other functions I made. So that means now our program can actually do something. I can call intro real fast, and then it'll return when it's done. If I just sort of run the program again, you can see after all the build messages, it's just printing that the module has started. Okay, so nothing super important yet. Now, what I'd like to do is capture some incoming arguments real quick, because let's see, standard input. Well, that's actually not going to work. Let's see, what do I want to do here? No, I think that's part of a different program. Okay. I'm going to call a demo. I don't think I need to add that one thing that I was just looking at. So I'm going to call a function that's going to be our main demo. So it's going to jump down somewhere. I'll just create the function down later. So let's see. Where is it? Standard input. So I'm going to start off by saying, this is my standard input function, which is this, and is this pop p, and then pop R12, and then it returns. If you don't know what a prolog and epilog are, or why I'm doing pushes and pops, just see my other videos. But basically, I'm going to be messing around with R12, so I'm responsible for preserving it. And I'm going to use the base pointer to help me remember where the stack started. I'm just going to choose to, what did I do? I started the wrong function. I'm going to do that one later. Okay, for now, let me go find where that other one is. Oh, there it is. Should have double checked. I'm going way too fast. I'll just copy paste this whole thing from my solution. So I'm going to do standard. This video is a mess. Honestly, it's a mess, but that's okay. I'm going to try my best to explain it. So I have this function, standard output, standard error, and I'm calling it here. So it should jump right down there as soon as the program starts. The standard input one, it's not getting called yet, but we'll call it at the end of this video. Basically, first I'm going to use my print null terminated string function to print a message to standard output. Remember, standard output was just, pipe 1. Standard error is going to be pipe 2. So if I go back here and I say I want to print this message to that pipe, then it'll go to standard output, just like the echo program was doing when we looked at it a moment ago. And then next we're going to print to oh, that was just an announcement that we're going to begin. So this is the real message that will say this is definitely going to standard output. And then this other message is going to go to standard error, which is when we looked at C error, or pipe number 2 a moment ago. So basically I'm just printing an announcement and then 2 important messages. One is going to pipe 1 and one is going to pipe 2 for standard output and standard error. Okay, like really not very complicated at all, right? So if I run this program now, hopefully I didn't crash it by copy pasting out of order here. Yeah, there we go. Clear and make run. So notice how it says that the messages are going to be printed. And then notice that both of my messages actually show up on the terminal. The one that says this message will print to standard output, number 1, pipe 1. And this message will print to standard error, pipe 2. They both get printed to the terminal because by default, the terminal will just take both of those pipes. It'll take 1 and 2, standard output and error. But I can use those little redirection tricks to mute one or more of those pipes. So I'm going to say pipe 1, which is standard output. I'm just going to redirect that to dev null to say I don't want to see standard output. If I run it again, notice how the only thing you can see on the string or on the screen is standard error, pipe 2, file descriptor 2. On the other hand, if I redirect file descriptor 2, pipe 2, to nothing, then I should see all the normal messages and not see the error message. Notice right here, it prints all the regular, makefile stuff and then the welcome message. And then here's our message that says this is going to be printed to standard output. So notice how the error message is missing. So cool. If I mute both of those, I can do that. I can say 1 directs to dev null and also 2 directs to dev null. Then nothing gets printed at all because that's all we really have is standard output and standard error. All right, not too bad, right? That's the basic idea between redirecting and things. You could also do things like this. If I, okay, this is not part of my plan, but suppose I wanted to take any error message and redirect it to, instead of dev null, I wanted to redirect it to some kind of a file. I could do that too. I could say hello, let's say standard error.txt. Notice how nothing seems to have shown up on the screen, but if I list the directory, now there's a text file called standard error that contains the error message. So you can redirect pipes, you can reattach them if you're like an elite hacker. You can do lots of things with them, but that's as far as I'm going to take it right now. I'm going to remove that. Now let's look at standard input. How do you send input to the program? Remember, when programs call other programs, they can send each other standard input too. It's just that when I launch something on the terminal, I'm just, I'm the human, and so whatever I type or what command I type is going to go into standard input if I do it the right way. So let's go back to the program here. Okay, so let's finish up standard input. And let's see, the pre-made code that I had here, I had the prologue and the epilogue, right? Move the base pointer, RBP and R12. Oh, I got to put the base pointer back into the stack pointer. Let's see, move. Again, this is not an assembly video, so just try to hang on here. So what I'm going to do in this video, I thought I was cute when I was making this plan. I know I'm not like that clever, but I thought, hey, wouldn't it be fun instead of having a global variable as our buffer, like in the data section or the BSS section? What if I just made the stack a buffer? This is kind of what you do when you make a local array in C++. You're making a buffer on the stack. So this is not a stack pointer video. So long story short, I'm just going to keep track of where the stack pointer started with this base pointer. That's why I have to preserve it there. And then I'm just going to subtract my buffer size from the stack pointer. And what is the buffer size? I've chosen to do a buffer size of about 8 kilobytes. So that means the user or me, I could send about 8 kilobytes, maybe 8 kilobytes or less into standard input and be sure that it's all actually going to be received by the program. And then I'm just going to use R12 to remember where the start of the buffer is, which is just wherever the stack pointer started. Because, if we subtract and then the data that increases is actually increasing in memory, but making room on the stack decreased. It's just the way it works. There's going to be another stack video out there. Anyway, for now, I just create a buffer on the stack. And then I'm going to print a little hello message. So I'm going to print this. So just my message saying, hey, we're about to do something from standard input. And then I'm going to send that to standard output. So the message is going to go to standard output, but I'm announcing that we're about to read from standard input. Assuming I actually cleaned up correctly, let me double check this. This should work and not actually take in any input. It should just simply say that it's going to without crashing. Okay, looks good. So then now I'm ready to actually read from standard input. We're going to use a system call from this. If you want more information on system calls, see my other videos, but basically you just go to the system call codes table, look up appendix area of whatever textbook you're using, and you say, what's the code to read? I want the system to read. So I define that as system read, and if you look up here in my program, it's just call code 0. So sys call code 0 is to read from somewhere. And then where do I want to read from? That's a second argument for the standard or for the system call. I want to read from standard input. That's going to be the number 0, if you recall. And then here is a pointer to the first character of wherever I want it to read into. So it's going to read from that pipe, but it has to write the data that it read somewhere so that I can save it and access it. So R12 is basically going to be a bunch of free bytes that I created on the stack. So I made the stack bigger, but it's mostly empty or with junk data. And R12 is just pointing to the first byte that I have reserved. So, you could imagine maybe you make a global variable in the BSS section up at the top, like an 8 kilobyte array of bytes, and then just sort of point it to that. But in my case, I'm just using the stack because I think it's cooler. So I tell it, hey, that's the first byte on the stack that I want you to start reading from. And then I give it the buffer size, which we just looked at, and then I do a system call. And then the system now should do all the hard work for me. It'll look at the pipe for standard input. It'll grab all of it. And then it will only grab, up to buffer size number of characters. It'll stop if the input ends before that. And then when I'm done, I should be able to actually read from the buffer, which is sitting at R12, and print it to the screen. So the next thing I'm going to copy paste in there is I'm going to print what I just read from standard input. So this is another call to my function. My little doggy wants to go pee, even though he's completely lying. He just went pee. So at this point, he wants to go outside and lift his leg and do nothing, and then come back in and demand a treat. I'll let him do it in a few minutes just in case, but trust me, he's lying. He's lied like 5 times today. Anyway, sometimes I regret teaching him to growl at me. It's so cute, but it's not cute right now. I don't know, maybe it is. Let me know in the comments. So basically I'm going to take that R12 buffer that I just wrote to, and I'm going to print that directly to standard output. And this is not really the important part of the video. So I'm going to do that, and then I'm going to kind of clean up here at the end of the function. And then maybe I'll say goodbye. I think I just added a string for that. So maybe I'll say goodbye. I'll say goodbye before we end the function, and then I'll actually return. So let me go here and run the program. Let's see, begin. Nothing actually printed because we didn't send anything, and we also didn't call that. Let me call standard input, call STDIN, and so now it's actually going to print basically nothing. Oh, I didn't send it anything, so it's just kind of hanging. You probably want to check this sort of situation, but that's not the point of this video. Let me show you how to pipe some stuff into standard input real fast. I'm going to go echo hello, and then just put a little OR bar in the shell. This will take the output of echo, and instead of printing it to the terminal, it'll attach its standard output into the standard input of make run. Pretty cool shell trick. So now we should see the word hello printed. And that's what it does. We have detected the following STDIN, and it says like, here's begin. That's just a string that I print every time. And then here's the string that it actually received, and then it ends. Pretty nice. I think maybe we could probably do the empty thing if I just started typing here, and then maybe I hit Control D to detach the buffer. And yeah, that's what it does. It sort of prints here, and then it ends there. Didn't do a new line. I think it probably doubled it for some reason because let's see, I didn't plan for this. Let me see. It printed, oh, because I did not null terminate the string. So actually what it did is let's see if we can do that real fast one more time. I'm going to go 1, 2, 3, 4, 5. Then I'm going to just disconnect the standard input buffer. Because the printing function needs a null terminator to know when to stop, there's not going to be a null terminator because I just typed and disconnected the input. So it's actually going to just continue to print through memory until it randomly finds a 0, and then it'll stop. So if I disconnect it, that explanation was bunk. Let me try that one more time. I'm going to go a bunch of H's. I guess there is a null terminator. If I disconnect it, no, see how, yeah, these little symbols there. So it does kind of print until it finds a null terminator. But I guess I was confused because it seemed like it printed it twice. What's actually happening is when I type, then it's getting sent to the terminal, and that's not part of the program that we just wrote. Then when I disconnect standard input, then the program finally prints everything that I actually typed until it hits a null terminator. In this case, it looks like it seems to have worked. But if I just do like a couple 7s and then disconnect, probably have to do this a bunch of times before we'll see those weird symbols again. Oh, what did I do? Hit enter. That seems to have worked. My dog is stressing me out, but I love him. All right, anyway, just trust me on this. Sometimes it's hitting the null terminator in time, sometimes it's not. But I hope by now you understand the difference between standard input, standard output, and standard error. Thank you so much for watching this video that I'm recording. And I hope you learned a little bit of stuff and had a little bit of fun. I'm going to let my dog lie to me for a second, and I'll see you in the next video. Hey everybody. Thanks for watching this video again. From the bottom of my heart, I really appreciate it. I do hope you did learn something and have some fun. If you could do me a small little favor, could you please subscribe and follow this channel or these videos or whatever it is you do on the current social media website that you're looking at right now. It would really mean the world to me, and it'll help make more videos and grow this community. So we'll be able to do more videos, longer videos, better videos, or just I'll be able to keep making videos in general. So please do me a kindness and subscribe. You know, sometimes I'm sleeping in the middle of the night and I just wake up because I know somebody subscribed or followed. It just wakes me up and I get filled with joy. That's exactly what happens every single time. So you could do it as a nice favor to me, or you could troll me if you want to just wake me up in the middle of the night. Just subscribe, and then I'll just wake up. I promise that's what will happen. Also, if you look at the middle of the screen right now, you should see a QR code which you can scan in order to go to the website, which I think is also named somewhere at the bottom of this video. and it'll take you to my main website where you can just kind of like see all the videos I published and the services and tutorials and things that I offer and all that good stuff. And if you have a suggestion for clarifications or errata or just future videos that you want to see, please leave a comment. Or if you just want to say, hey, what's up? What's going on? You know, just send me a comment, whatever. I also wake up for those in the middle of the night. I wake up in a cold sweat and I'm like, it would really mean the world to me. I would really appreciate it. So again, thank you so much for watching this video, and enjoy the cool music as I fade into the darkness, which is coming for us all.